Welcome to a slow, beginner-friendly lesson on connecting to a database and creating tables in Python, made for absolute beginners. Databases begin here. Today we open your first real database inside Python. Until now you saved data in memory, variables, lists, dictionaries, and everything vanished when the program stopped. A database changes that. It writes data to a file on disk, and it stays there forever until you change it. Today you meet the built-in SQLite 3 module. You learn how to connect, how to create a table, and how to describe its columns and types. Slow, one idea at a time. From memory to disk, SQLite 3 is the database that ships inside Python. You do not install anything, you do not run a server, you do not open a port. The entire database lives in one ordinary file on disk, with the .db extension. That makes it perfect for learning, for small apps, for tools, and for prototypes. The module you import is called SQLite 3, lowercase, the number 3 at the end. It is one of the friendliest ways to start working with real persistent data in Python. No server, just a file. Until now, your data lived in memory. Memory disappears when the program ends. A database writes to disk, and disk remembers. Built in, ready to go. First step, import the module. Write import space SQLite 3. Python loads the module from its standard library, no pip install, no UV add, nothing extra. You can confirm it is loaded by typing its name. Python prints back a module object and where it came from. From this point on, every database feature you need lives behind that single name, SQLite 3. Connect, cursor, execute, all of it starts with this one import line at the top of your script. The doorway into data. Now you connect. Write con equals SQLite3.connect, and pass the name of the database file in quotes. Here we use app.db. Python opens that file if it already exists, or creates it brand new if it does not. The result is a connection object. You usually store it in a variable called con. The connection is your doorway into the database. Through this one object you send commands, read results, and save your work. Close it when you are done. Open the file. Let us look at the connection object. Type of con gives SQLite3.connection, its own class. The connection holds the open link to the file on disk. Through it, you control transactions, you create cursors, you commit changes, and at the end you close the link. Think of the connection as your session with the database. Everything you want to do, read, write, update, flows through this object. One connection, one session, many commands inside. One session, many commands. From the connection, you ask for a cursor. Write cur equals con.cursor, open close parentheses. The cursor is your tool for running SQL. Think of it as a finger that walks over rows of data. You use it to send commands like create, insert, select, and update. The connection manages the file, the cursor does the actual work of talking to the database. In small scripts you usually create one cursor and reuse it for every command. Store it in a variable called cur. The finger on the rows. Two objects share the work. The connection manages the file. The cursor runs the commands. Together they move your data in and out of disk. Two tools, one job. Working with a database follows a simple rhythm. First you connect, opening the file on disk. Then you ask the connection for a cursor, your tool to send commands. You call execute on the cursor with your SQL. When your command changes data, you finish by calling commit on the connection. That is the moment your work is truly saved. Finally you close the connection. 5 steps: connect, cursor, execute, commit, close. You will repeat this pattern every time you touch a database in Python. 5 steps, every time. Now you run your first SQL. Write cur.execute, open parenthesis, then a SQL string in quotes. Here we create a table called users with 2 columns, it is an integer, and name is text. Execute sends the SQL into the database through the cursor. The cursor object comes back, because in Python execute returns itself, that is just how the API is designed. The table is now defined inside app.db. But there is one important step before it is truly permanent, and we cover that next. SQL goes through the cursor. A short word about SQL. SQL stands for Structured Query Language. It is its own language, separate from Python, used by almost every database in the world. You write SQL as strings inside Python, and SQLite 3 sends them to the database. You do not need to master SQL today. In these lessons we use a tiny, safe subset: create to define a table, insert to add a row, and select to read rows back. 3 commands. That is enough to start storing and retrieving real data. A small, safe subset. Here is the full shape of a create table command. You write create table, then the name of the table, then a pair of parentheses. Inside those parentheses, you list each column on its own line, separated by commas. For each column you give a name and a type. This user's table has 4 columns, it is integer, name as text, age as integer, and email as text. The triple quotes let you spread the SQL across multiple lines, which makes it much easier to read than one long string. Columns have types. SQLite gives you a small set of column types. Text is for strings, names, emails, anything in quotes. Integer is for whole numbers, counts, ages, IDs. Real is for decimals, prices, measurements, anything with a point. Blob is for raw binary data like images, though we will not use it much. These 4 cover almost everything you need as a beginner. Match the column type to the kind of data you plan to store. Names go in text, ages go in integer, prices go in real, that is the whole idea. 4 types cover most needs. Almost every table has a primary key. The primary key is a column, usually called id, whose value is unique for every row. Write it integer primary key, and SQLite takes care of the rest. When you insert a new row, SQLite picks the next integer for you, 1, then 2, then 3. No 2 rows ever share the same id. This lets you find one specific row later, update it, or remove it, with no confusion. Make the primary key the first column of almost every table you design. Every table wants one. There is one sharp edge to know. If you run create table twice with the same name, SQLite raises an error, table already exists. That is annoying when you rerun a script during development. The fix is 3 simple words, if not exists. Write create table if not exists users. SQLite checks first, does the table exist? If yes, it does nothing and moves on. If no, it creates it. This makes your script safe to run again and again. Always include if not exists when you create tables inside a script. Safe to run twice. You define columns. You set a primary key. You guard it with if not exists. A table now lives inside app.db. The shape is ready for rows. The table is born. Now the most important habit in databases, commit. Write con.commit, open close parentheses. Commit is the moment your changes are truly written to the file on disk. Without commit, your inserts and table creations live only in memory. Close the connection without committing, and SQLite rolls them back, gone, as if they never happened. Beginners often forget this and wonder why their data vanished. Always call commit after you change data. Read operations like select do not need commit, but create, insert, update, and delete always do. Save it or lose it. When you finish, close the connection. Write con.close, open close parentheses. Closing releases the file lock so other programs can use the database, flushes any pending writes, and frees memory. A database file left open by a forgotten connection can cause weird errors later, other tools may not be able to open it. Get into the habit now, open, work, commit, close. 4 steps, every script. If your script crashes before close, Python will usually clean up, but do not rely on it. Close explicitly when you are done. Close every time. Python offers a cleaner pattern, though with block. Write with SQLite 3.connect as con:. Inside the block you do your work, create a cursor, run your SQL, commit. When the block ends, the connection closes automatically, even if something inside went wrong. This is the same idea as opening files with open. It is safer because you cannot forget to close. Note that with does not commit for you, you still need to call con.commit before the block ends, or your changes will not be saved. With closes for you, there is one small setting that makes SQLite much friendlier, the row factory. By default, SQLite returns rows as plain tuples, so you read fields by position, row 0, row 1, row 2. That is fragile and hard to read. Set con.rowFactory equals SQLite 3.row, and rows come back as objects you can access by column name, row square brackets name. This is a huge improvement when you have many columns. Set this right after connecting, before any query. One line, much nicer code. Read by name, not number. Now let us put it all together. We import SQLite 3. We connect to app.db. We set the row factory for nicer rows later. We create a cursor. We run a create table if not exists command with it as primary key, name as text, and email as text. We commit so the table is saved. We close. About 10 lines, and at the end you have a real database file with a real table inside, ready to accept rows. This is the smallest complete pattern, and you will reuse it everywhere from here. The smallest complete pattern. Quick self-check. Can you import SQLite 3 and connect to a file called app.db? Can you create a cursor from the connection? Can you run a create table command through execute? Can you explain why commit matters, and when to call close? If any of these feels shaky, rewatch the matching part. Say each line out loud as you type it. The muscle memory matters more than memorizing syntax. You will use this pattern in every database script from this point on. Say each out loud. Here is the lesson in one breath. SQLite 3 ships with Python, so there is nothing to install. The flow is always the same: connect to a file, get a cursor, execute your SQL, commit your changes, and close. Use create table if not exists so your script can run twice without errors. Give every table an integer primary key called id. Set the row factory to SQLite 3.row so you can read columns by name. That is the foundation. Everything else in databases builds on these few moves. The foundation of databases. Next lesson, you learn to put data into the table, the insert command. Then you learn to read it back with select. Then you add a where clause to filter results. Your database now has a shape, a real file on disk, with a real table inside, with real columns defined. What it does not have yet is rows. That comes next. Once you can insert and select, you have crossed the line from learning syntax to building real data-driven tools. The work continues. Rows come next. Thanks for meeting SQLite 3. Next we add rows with insert and read them with select. Tables are ready.